Greetings, everyone. Thank you for coming to our talk about adding controller remapping to Destiny 2. My name is Lisa Brown. I am a gameplay systems designer, and while I was at Bungie, I was the feature lead on controller remapping.
Hi, I'm Jen Ash. I was the UX designer and feature lead for the player identity UI UX small team that worked on controller remapping.
So this summer, in the Season of Arrivals release for Destiny 2, we shipped controller remapping. We're going to talk today about the journey of how we got there and some of the challenges we faced with retrofitting controller mapping to an existing, established live game rather than building it from the ground up. Jen will do a review of the implementation details of our remapping screen, and then we'll go over some surprises we ran into and some tips for folks who maybe need to do something similar for their game. If you're unfamiliar with Destiny, it is a first-person shooter that's a live service game with a big audience. Destiny 2 launched in 2017 and has been continuously updated with expansions and seasonal content, meaning we didn't have the advantages of building controller remapping in at the beginning of development. We had to adapt it to existing systems. One of the things Destiny and Bungie are known for are buttery smooth, responsive controls. This is key for an action game and something we had to maintain while building remapping. At the time of release, we had a number of controls presets and some accessibility settings like the ability to swap bumper and trigger functionality, but no true remapping. So first, I want to talk about the process of getting this feature approved. Pretty much everyone on the team knew this was important to do and wanted to do it. Our player identity team had done explorations on accessibility resources and potential areas of the game to improve, and controller remapping was high on the priority list. And the sandbox team, who is responsible for core player systems, had always desired to do true remapping. Unfortunately, the feature kept getting deprioritized because of the game's aggressive content schedule, especially with regards to UI needs for new features. At the launch of Destiny 2, we were hopeful that we could leverage the work Vicarious Visions did on the key mapping functionality for the PC version. Unfortunately, it ended up not being the case for a number of reasons. We used a proprietary engine at Bungie, and key binding was built with a completely different and separate system than what we were using for controllers. For example, there was no broad support for the concept of holds versus presses, and a lot of things were built for one-off support. However, we were still able to leverage this work as a baseline reference for what things should be remappable in a minimum viable product version of controller remapping. So, how did we eventually get it to happen? I got together a small team of accessibility passionate folks, and we did some due diligence research to figure out exactly what the scope and the resources we would need to ship this feature. Not everyone here was on the eventual team that built it, but they were key in gathering the information. We'd also just done some reorganizing in team structure, consolidating systems as a team, so I took this information and pitched it to systems leadership. Accessibility was one of our systems team's values, so I focused on that. Plus, I am known to be somewhat of a rabble-rouser on this topic, so I kept bringing it up and pinging to make sure it didn't fall through the cracks. The most important step after leadership approval was getting the feature on our production roadmap. Destiny has a team of about 700 people and is constantly shipping content. Getting it on our roadmap was the most important step for land grabbing those highly sought after UI resources early enough that we could commit to the feature. And this was important because the UI work for this feature ended up being pretty bulky.
One challenge we faced to how to compose the team to build the feature. At Bungie, we have our teams broken into dev groups, then areas, and then small teams due to the sheer amount of people working on Destiny 2. It didn't really fit nicely into one of our pre-existing small teams, so we built a strike team. The strike team consisted of 3 different areas collaborating. We had sandbox engineering and tests from our combat area, we had sandbox design, Lisa, from our weapons small team under the rewards area, and we had production and UI small team support from the player identity area. The strike team was important because it allowed us to bring in different disciplines to the feature development early in order to identify cross-team work, such as work from localization and narrative. While they may not be building direct functionality for the feature, they are directly impacted by it. You'll hear more about the challenges with strings and verbs later in this presentation. A very important tip if you find yourself in a similar situation, make sure to give the feature an official home, where it lives in the backlog, etc. This helps to make sure nothing slips through the cracks and also makes it so it won't get lost for future development. For Destiny, even though most of the strike team for controller mapping was from player identity, the feature lives on the combat team because of its intrinsic tie to combat verbs. So, if Bungie wants to do another round of improvements later, it'll start with a combat team. In addition, we knew it was important to get accessibility consultants on early. We had Cherry Ray Thompson and Ian Hamilton as consultants. Cherry had actually come to Bungie and given a talk about accessibility as part of our diversity speaker series. So we were like, oh, we definitely need to get them. Our producers handled obtaining the contracts and the budget for that. We frequently sent our consultants questions on how to prioritize aspects of the feature, layouts for reviews, and sought help on general feedback regarding the feature.
So now I'm going to talk about some challenges that were specific to our game that we faced when we began developing controller remapping. We looked at a good number of competitive games for both feature identification and implementation details. We tried to focus on games that had similar complexity, specifically ones called out by the accessibility community as having done controller remapping really well. It definitely helped us understand the problem space better, but we discovered that Destiny had specific challenges that these other games didn't, and we would have to figure those out. The biggest is that Destiny has a ton of verbs. A verb, in this sense, is an action that the player can take in the game, like shooting or jumping or crouching. And we had more verbs than there were buttons available on the controller. We were already overloading it. Simple button swapping wasn't going to get us what we needed, because we had things like double press the crouch button to dodge, and hold the grenade and melee buttons to cast super, and press this button to throw a grenade, but hold the button to consume the grenade. We were going to need a lot more. Our solution to this was to leverage input types that we were already having players do, and make them mappable separate from the button. These input types were press, so for example press B to crouch, long press, like holding the button to cast rift or barricade, and double press, like the hunter dodge. Doing this helped open up our button space and also reduce cognitive load for people already familiar with the game, since they were doing these actions anyway. We also leveraged the fact that we had a chord in our game. A chord is when two buttons can be pressed at the same time to register as its own input. In Destiny, our chord was pressing both bumpers at the same time to cast your super. We ended up generalizing chord support so that any two buttons could combine to become a chord. Lastly, we prioritized flexibility, meaning that we didn't have restrictions on what could be mapped to what. These three things gave us enough room for a robust remapping system. After we committed to this direction, the Ghost Recon beta came out and showed us that they were doing something similar as far as letting players map input type. So we were reassured that this method wasn't too far off the mark. Now I'm going to go over some decision criteria that we had on the gameplay implementation side. Basically, how we made decisions on what to add and what to leave behind when getting the MVP version of the feature built within scope. For technical implementation, we found we were making decisions about this feature in a sort of informal decision-making triangle, because there were three things we were always trying to balance with each other. Those things were user-facing complexity, adherence to the original player experience, and one-off handling and code. So for example, if something required one-off code to make the player experience more like the original, how would we balance those two things? Here are some examples of how these manifested. In general, we tried to avoid adding user-facing complexity where possible. For example, when thinking about our three input types, press, double press, and long press, we realized that press could be broken down into two other types. A tap, where the action initiates on button down, and then a press where the action doesn't initiate until button release. This would have opened up even more options for the players to remap. But we decided in the end that the user-facing complexity this would add to the remapping screen and explaining what exactly these terms meant to players was going to add more cognitive load without much payoff. So we stuck to our original three inputs. One place we did add user-facing complexity to good effect was adding a slider to let players adjust the delay between button presses for it to count as a double press. Even though this involved additional UI, it was straightforward to explain and had a high accessibility payoff. Adherence to the original player experience was an important consideration anytime we thought about adding complexity or one-off code. One example of how this worked was weapon swapping. In the pre-mapped world, you pressed the Y button to switch between kinetic and energy weapons, and held the Y button to swap to your power weapon. With remapping, we followed the less complex PC options for how to swap weapons. You could map a binding to the 3 weapon slots separately, or bind to a previous next weapon model. However, we chose to still keep that original weapon swapping paradigm, even though it added complexity, because we didn't want to disrupt how most players were used to swapping weapons. On the flip side, one place where we didn't nail the original player experience was how we implemented remappable sprint. We had followed the PC paradigm of having an option for hold sprint and an option for toggle sprint. However, on the console version, our sprint button wasn't a true toggle. It was more of an initiate sprint button. So you'd press the button to sprint, but if you already were sprinting and pressed it again, it wouldn't turn off the sprint, it would just reinitiate it. When the feature shipped with sprint re-implemented as a toggle, we ended up breaking some things, including a skill called sprint canceling, which is when people used the sprint button to cut a weapon reload animation short. Now when they did this, they stopped sprinting altogether, which was not adhering to the original player experience. We fixed this bug in live by making the toggle back to a sprint initiate behavior. But in truth, we really needed 3 sprint options: hold, toggle, and then one for press to initiate. Next up was one-off handling of things in code. We tried to reduce this where we could for scope and complexity, which meant prioritizing player flexibility in their options instead of trying to protect them from bad states. Here's one example of how this manifested. If you map melee to press X and then map finisher to long press X, the finisher will never happen. This is because the time it takes the melee action to resolve is shorter than the threshold for a long press to kick in. We poked at this problem a lot to see if there was a way to resolve it in a one-off way, since this was a specific case we expected players might want to do. But ultimately, we decided to reduce the need for a one-off handling case and left it in. There were still cases where we decided to add one-off complexity, though. One example of this is how our code handles supers. Before we added general chord support, supers were built as a chord interacting with the melee and grenade throw actions. In the new system, we still rebuilt the super in this way, which was different from how other chords worked. This trade-off was to maintain the original player experience in terms of how our action resolution worked, as well as cut a lot of situations that would rely on this old paradigm. Now I'm going to turn it over to Jen, who will go over the details of the UI implementation of our remapping screens.
There are many ways to approach controller remapping for individual games, and there are a number of subtle differences, so I wanted to cover some of the details we included in our version. One aspect that often gets brought up is there isn't enough time to implement this feature. The UI UX team that worked on the feature was the Player Identity UI UX small team. We were fortunate to have 2 engineers on our small team so that we could have 1 dedicated engineer on the feature and still be able to react to other features being developed during the release. That said, the tech spec still took about a month to complete. Implementation was intended to run for 2 months. However, due to complications with verbs and strings, which will be covered in the next section of this talk, it ended up taking about 3 months of dedicated engineering time to complete. The takeaway? Always include buffer time in your schedule. Buffer time can account for holiday vacations, illness, etc., but it's also important to consider the unknowns that might crop up due to found work. Another aspect that gets brought up often is why not include UI remapping as part of the feature. From our technical UX designer, Andrew Davis, there were a number of different reasons we didn't implement UI input remapping. Our sandbox system already had the conceptual basis for swapping out which actions were tied to which button presses to support the various controller layout presets, but the UI systems did not. To extend that system for UI, we would have to convert all the hard-coded inputs into verbs that could be remapped. Once we updated each system that captures input to understand the remap buttons, we would then need to touch hundreds if not thousands of places in the UI where we were looking for that particular button press. It would also add to the potential of additional button conflicts. Sandbox has an input priority system to handle those, but UI currently does not. In addition to that, if we didn't do work to protect the user from misconfigurations, they could end up in a situation where they've unbound the open menu or select action and not be able to access the settings screens to fix it. Destiny 2 already had preset profiles that players could choose from, such as mirror and green thumb. These swap buttons for particular verbs, but not very granularly. We knew we had to integrate a new profile into the 6 existing profiles we had, so we created a drop-down at the top of the page to allow players to select an existing preset, and it allowed us to have flexibility to add future profiles to the bottom of the list. Part of adding a custom profile came the decision of where does that information get stored. We decided it was best to save it to the player profile instead of the platform profile. This allows for a consistent experience even if players say go visit a friend. While we discussed supporting 3 different profiles, it was risky for the release timing. With only supporting one, we allowed ourselves buffer time to support discovered work, which ended up being necessary. Also, if we were to support more than one profile, we would want to support renaming to aid in players remembering the different nuances between the profiles, which would add additional work to complete for this feature. Another aspect we had to address was what context the input was going to be used. The verbs available to players are different depending upon their game state, such as if they're in first person versus in a vehicle. We decided we need 3 contexts: character, vehicle, and additional settings. You'll notice the navigational structure resembles the interactions players take elsewhere in the game, such as the inventory screen. This helps build off of players' existing mental models. In addition to supporting inputs for the verbs in the game, we were also now supporting different input types: press, long press, and double press. We have 2 potential navigation interactions for similar options selection in our game: carousel click, where you only see one option at a time that cycles through, and drop down. We decided to go with a drop down to allow players to see all options available on selection. This also exposes the icons we created for each input mode for easy comparison. One key aspect to this feature we had to figure out was how players changed inputs. Some games have the input directly on the main page, where you select the input, the screen records the next action as a changed input, and that's what gets recorded. Others bring up a special overlay. We decided to go with an overlay. The overlay has benefits, especially for those with motor control challenges. It allows for control over activating the record mode for a particular input before moving away from the screen. When the player first opens the overlay, we highlight the input box to draw attention to it. The overlay is particularly useful since we support chording, or 2 inputs at once, for all verbs, which can be challenging to get right the first time. The cursor does not move during recording mode, so player can select the input box again to record new inputs with 1 button press. The overlay also allowed us to communicate limitations and words of caution to players. For example, we have a limit of 2 buttons that can be combined or recorded. We can be upfront with players about those limitations so they understand what's available to them. We also didn't have time during the release to implement smart conflict notifications, so we wanted to highlight this to players by including it in a caution box. One feature our consultant Cherry called out was adding the text description for input. This aids players in not having to identify the button glyph by itself, but also enhances the input choice with the description. Once a player has selected a new input, we draw attention to the confirm button by coloring it green. This helps provide feedback that the input was accepted through both color and state change, and the player can choose to continue or not. We implemented a reset to preset option for players for 2 reasons. First, it allows players to quickly start their custom layout with a preset they typically use to aid with potentially limiting the number of changes they want to make to their layout. For example, if you normally used green thumb, you could select this as your custom base and only change a couple buttons to what you want. Second, it allows for players to reset their choices based upon a preset of choice instead of just the default option. Calling back to reusing common navigation methods, you may recognize the selection layout. We use a similar interaction for selecting activity difficulty. Once a player selects a reset layout, we pop a dialog to confirm their choice. Since players could potentially spend a lot of time editing their layouts, we had to make sure it was clear to players when a destructive action was going to take place. The final aspect I'm going to talk about is the ability for players to unbind their inputs. To help players with flexibility and error prevention, we allow players to unbind single inputs. We considered placing it in the set binding overlay, but ultimately we decided it made the most sense on the button layout screen itself. This way players can identify 2 potential overlaps of inputs on the screen at a time and change them while still visible. You'll notice we also included the button input description on the input tooltip, so players once again didn't need to rely on identifying the correct button glyph. Now I'm going to hand it back to Lisa to go over a few surprises we ran into during development and some tips that might help folks who need to add remapping into their existing game.
All right, so one particularly surprising issue we ran into was with localization and how we represented buttons and inputs in strings. Before remapping, our strings were written like this: a natural sentence where the button token would point to an image of the glyph of the button on the controller. So press button token to throw grenade would show the glyph of the R1 button or whatever it was mapped to in the preset you had selected. With the new system, we now had 2 tokens instead of one for input and one for the button, and the input token was an English string. Our initial instinct was just to rewrite the strings like this, replacing the written word press with the input token of whatever the player had selected. So input token, button token to throw grenade. Here's the problem though. Because that input token is an English word, this format was not guaranteed to be localizable in all languages due to grammar rules, sentence order, and verb rules in a number of languages that we support. So we had to get together with the localization and narrative teams to figure out how to solve this. Our solution involved rewriting all strings that referenced controls so they were no longer natural sentences. Instead, we would show the input, show the button, then separately describe what this combination did. This ended up being the best solution we had with the time and resources available to us, but it did involve a massive editing pass. The next issue might be a controversial topic since it yielded some live bugs, but we decided that rather than keeping our old bespoke presets in their old system and having remapping alongside of them, that we would rebuild all our presets in the new remapping system. This had some pros and cons. The pros were it made it much easier for players to make a single change on top of an existing preset, since you could easily copy a preset as a base for your custom layout. It also made it faster to find bugs, since in development we were essentially switching everyone over to using the remapping system, even if they were using their default presets. The cons, of course, were more bugs on launch. Remember how we broke sprint canceling? However, we feel like this trade-off was worth it for the benefits we got, and the bugs that we found in live were resolved in the next couple of patches. If you're in our situation where you have an existing game that's been out in the wild for a while, and you're adding remapping to it, here's a few development tips that might help you. Keep your old bespoke system functional alongside your new remappable system as long as possible to be able to compare. Ideally, keep an old build of the game functional past ship, so you can go back to compare for bugs that will crop up in live. Our sandbox engineer ended up having to boot up Destiny 1 at home to compare some specific behavior. Handle commands in a deterministic order, ideally one defined in content that you can manipulate easily. This reduces the test matrix and allows you to spot fix some bugs. For example, process double jump before jump so it can suppress the jump input and prevent a jump from being queued right before landing. On the inspection and testing side, make it as easy and fast as possible to change configurations, and again, to be able to compare to the old system. Before we had any UI work done, we were able to use a text CVARS file to change the remapping and load it live in the game, which expedited testing. Plus, we were able to easily switch it off with a single input command. We also had some good debug visualization for which buttons were mapped to which verbs at any time. So, for all this work, did the feature actually work? Did it actually help people play our game more easily? I went to Twitter and asked folks for examples of how they were using the system. And here's a few of the quotes that I got, kept anonymous by request. I have psoriatic arthritis and have a difficult time clicking in thumbsticks. Due to this, I never used finishers until remapping. Mapped finisher to up on D-pad and now I use it all the time. I sawed off part of my left thumb and remapping the sprint to the right thumbstick was a godsend. Playing Destiny without being able to sprint is just not very fun. Very happy with the feature. I remapped crouch from B on a regular Xbox controller to R3, the stick click. This allows me to slide and aim scan an area better while sliding. I'm starting to get older and my fingers seem to be tougher to play. I've completely remapped my setup and got back triggers and the pain has been relieved. I rebound sprint to L1 and bound grenade and finisher to down D-pad and right D-pad respectively. Repeatedly pressing L3 had ended up straining my thumb. I have 2 remappable buttons on the bottom of my controller where paddles would be on a SCUF controller. I remapped the one on the right to jump and the one on the left to crouch. Makes it easier for me to rotate my camera while jumping and moving around and sliding. So I would say from those, even though it's a small sample size, that we definitely affected people and definitely enabled more people to play. People used it either to just optimize their own play or to literally do things that they weren't able to do before in our game. So let's do a summary of what we talked about today. First of all, controller remapping, applying it to an existing game that's already launched, is hard, but it's so worth it. You can see that it really affected people's ability to play. Champion the feature early and often. It's one of those important but unurgent things that can easily get deprioritized if you're not constantly checking on it and making sure it doesn't slip through the cracks. Competitive analysis is great, but there's no one-size-fits-all solution for every game. You'll have to figure out the unique challenges that your game faces and figure out how a remapping solution would fit what you have. Use consultants. Our accessibility consultants were so helpful in calling out things that we would have completely missed without them. They really saved us a lot of time and I believe made the feature a lot better than it would have been without them. And lastly, well, not lastly, expect surprises for fitting your remapping feature into your current tech. Run it by area experts early. There's always going to be something weird that pops up. And lastly, the UI will take a really long time, but it's important to get it right, so make sure you budget those resources appropriately. Thank you for coming to our talk. I hope that it was helpful.